Lesson 5.4, equations of graphs of trigonometric functions. So we want to recap from yesterday. So in this first question, they're looking at cos of n theta, and we know that it has the same period as graph of tan theta, and they want to know the value of n that would make that true. Well, for tan theta, we know that the period is equal to pi. And for cos theta, we know that it's equal to 2 pi. So in order for them to be equal, we would have to divide this value by 2, which means that that would be our b value right here. Okay, so by dividing by 2, that gives you the b value, because normally we would have to take the reciprocal of it in order to actually be the factor that would multiply by your period. So n would have to be 2. So that's your b value. So that is equal to your b value in this equation. Our next question, they want the general solution for tan squared theta minus 1 equals 0. So we need to solve for tan squared theta first by moving the negative 1 over to become positive 1. And then we're going to square root both sides, but what we need to remember is that tan theta could be positive or negative 1. So our next step would be to find what theta is equal to. So theta would equal tan inverse, so this is the reference angle that we're finding right now, of positive 1. So that is our reference angle, and this is going to be in radians. So that's going to be 45 degrees, which is pi over 4. So that's equivalent to 45 degrees. So where tan theta could equal positive or negative 1 could be in every quadrant. We can have a solution in CAST, quadrant 1 all the way to 4. So there's a solution in every quadrant because the solution can be positive or negative. Now, we need to find out all the solutions where that will occur. Well, we know that the first one would be pi over 4. And then if you take pi and subtract pi over 4, that would be like saying 4 over 4 minus pi over 4, which is 3 pi over 4. And then if we have our next value would be in quadrant number 3, we would have to go pi plus pi over 4. So that would be 4 pi over 4 plus 1 pi over 4, which is 5 pi over 4. And lastly, if I take double, which is 2 pi. So if I have 2 pi and I subtract pi over 4, that's how you get the angle, the rotation angle in quadrant number 4. So that would be 8 pi over 4 minus pi over 4, which is 7 pi over 4. So we need to figure out a way to represent all the solutions using all of these. How do I go from here to here to here, etc.? So we can represent this using one kind of general theory, is that theta can equal, if I take pi over 4 and I take 2n plus 1 and multiply it, that will actually represent, if n is an integer, it will represent all these. For example, if I put a 1 in there, 2 times 1 is 2. 2 plus 1 is 3. So 3 pi over 4 represents this guy right here. If I put a 2 now for n, that'll be 2 times 2 plus 1, which is 5 pi over 4. So that represents this guy right there. If I put a 3 there, that'll be then 6 plus 1, which is 7 pi over 4. And then if I put a 0 for n, that gives me then 1 pi over 4. So that could represent all the solutions that are possible if I go around this circle. So this is the general solution that works for every single answer here. Example number 1, they're asking us to work in degree mode. So we need to solve for sine x first. So we're going to move the 3 over to the other side. And so that's going to be equal to 3, and then divide by 4 on both sides. And then we need to square root both sides, so that gives us positive, negative, square root of 3 over the square root of 4 is 2. So that again can occur in every quadrant because it can be positive or negative when we're looking at the cast rule. So next step, we're going to do x is equal to the sine inverse of root 3 over 2. So our reference angle, if you take that, make sure that you are in degree mode when you're doing this question. So sine inverse of root 3 divided by 2. You can also look at your special triangle if you wanted to, and that would be equal to 60 degrees. So we're in degree mode, so this is 60, this is 60, this is 60, and this is 60. So in quadrant number 1, we know that the solution for x could be 60 degrees. Then for quadrant 2, you take 180 minus 60, which is 120. And then we have another, if we have 180 plus 60, which is 240. And then we have 300 for quadrant number 4. So they're not asking for the general solution, they just want the solution between 0 to 360, so that would be all these solutions right there. Determine the general solution for this exact trig function. So I'm going to do this one graphically. You can actually do this one graphically or algebraically. I find that this one would be nicer to do graphically. So what you can do is you can put y1 is the left side of your equation, which is 10, and y2 is the right side of your equation, which is 6 sine pi over 4 x plus 8. So this is another way to solve for any type of equation where you put the left side into your y1, the right side into your y2, and we're just trying to find out where they intersect. So it is asking for the general solution. So 10 is y1, so I'm putting this into my calculator, and then 6 sine, make sure you put pi divided by 4 in brackets with x. Close the bracket and then add 8. So this has to be in brackets if you're going to get the right answer. And then switch your mode to radian mode. Now for your window for y, so I'm going to write down what my window was to be able to see the solutions. So I'm pretty much going to look for the answers between 0 and 2 pi and then go from there, because once I know 1 full rotation, but I do need to find out the period. So the period is normally going to be 2 pi, but it might change because of this this b value. So it's always going to be your period is 2 pi divided by your b value, which in this case is pi over 4. So that would be equivalent to doing 2 pi multiplied by 4 over pi. The pi's cancel, giving us 8. So our period is actually going to go from 0 to 8. So that's 1 period. 0 to 8 going up by 1. So that's the scale I'm going to set for my x value. So use your period as a hint. And then your range, we know that our graph is going to go, the midline is going to be at 8, and it's going to be 6 above that and 6 below that. So I'm going to go from 2 up to 14. So that will go from the minimum to the maximum, and that would be 1 cycle. So we need to figure out all the intersection points. So your next step would be to go second trace number 5. So we want to find the intersections by going as close as possible to the 2 intersections. So when we graph this, it should look like something like this. There's our value. Okay, so we want to stop there. Oops. We want it to stop there, and so these are the two intersections that I care about. So second trace, the first one, actually the second one would be 3.56, or 57 if you round to the nearest hundredth. And the y-coordinate we don't really care about right here. It's just the x-coordinate that we need. And our other intersection that we need is, so you want to move as close as possible to the intersection. So I get 0.43. So once you find your 2 points within that one cycle, it is, the general solution just looks like this. X could equal 3.57 plus 8n, where n is an integer. And then your next x could be the value that you found within that cycle, 0.43, plus 8n again. The 8 represents the period, so how long it takes for you to repeat that cycle again. So that would be the general solution that they're looking for. Example number 3, in some Caribbean countries, the current makes 50 complete cycles each second, and the voltage is measured in V equals 170 sine 100 pi t. Graph the voltage function over 2 cycles. Explain what the scales on the axes represent. So it would be helpful to find your amplitude and your period, because that helps you draw it properly. So let's do B first. The period is always equal to 2 pi divided by the value in front of t. So 2 pi divided by 100 pi is what I'm trying to simplify. The pi's will cancel, leaving you with, if you divide these values, 2 divided by 100 is equal to 0.02, and that's going to be in seconds. So this is how long it takes for this to repeat itself. So if I want to draw 2 cycles, you just need to multiply your period by 2. So I know that I need to draw this over 0.04. Now, there is no d value, so there's that means that your vertical displacement is 0, so that means it's going to be on the 0 line. So at y equals 0, it's going to be going through that value right there. But I do know that the graph is 170 units above that that x-axis, and it's also 170 units below that x-axis. So what I'm going to do is take 170 and divide it by 5, because that's how many sections there are. And I know that I should kind of split it up as 40. Going up by 40, 80, 120, 160, and then 200. Just to be able to get to 170. And same thing below. And then since I kind of want to split this a little bit, so I want to split this 1, 2, 3, 4, 5. I'm going to go up by 5, so 0.01 would be that value. 0.02, 0.03, should be by 5 actually. Okay, so once I have this marked, the x-axis will be labeled for time, and V is your voltage that we're using. Okay, so we know that the graph is going to go through these values of 0 0.01, 0 0.02. If you find your x-intercept, 0 0.03, and 0 0.04. So we know it goes to the maximum at, so halfway in between that first, those two first x-intercepts. I know it's going to go to 170. So I'm going to draw a line going, or the graph going through there. Then it's going to go to the minimum, and again at 2.5 units away from 0 0.01 and at negative 170. And just repeat that. So this is 2 cycles that I'm drawing here. Okay, so we know that we're talking about the voltage in comparison to time. So what we know is that it reaches its maximum voltage between 0 and 0 0.1, and we're talking about seconds, right? So in this case, we have it reaching our maximum and then minimum voltage, and it goes back up to the max and minimum voltage. We found the period already, which is B, and then for C, they want to know how many times does the voltage reach 110 volts in the first second. Okay, so what we want to do is we want to draw a line at 110, which would be approximately here, and we want to find all the times that it intersects. And that's all the way to 1 second. So there's a few intersections that we actually need to find. So remember, it's going to happen. So we know that it's going to, between 0 and 1 second, between 0 and 0 0.01 seconds, we know that it is going to reach a voltage of 110 twice. So 2 times is when it's going to reach it. Now, if we take 60 seconds and divide it by 0 0.01, we know that there's 6,000 of them. And then we can use our scale to figure out, it says that there's going to be 50 complete cycles per second. So 50 cycles per second. Now, we know that we're multiplying it by 2. And that's going to occur 100 times then. Example number 4, Windsor, Ontario is located at a latitude of 42 degrees north. So they're giving us a table where we have the hours of daylight by day of the year in Windsor. So this is our day, and this is the hours of, in this case, daylight. So when we look at a chart, we know that the first row in this case is our x value. We're going to label it as L1, and your y coordinates are going to be labeled as L2. So what we want to do is we want to draw a scatter plot of this data on the below grid. So we're going to put day along our horizontal axis and hours of daylight along our vertical axes. So we know that in a year we have 360 days, so we can divide this, and we can go up by, if you want, by 20. So 0, I'm going to skip just to give myself some room, 40, 80, 100. Actually, I want to go up by, so it's going to be 120, 160, 200, 240, 280, 320, 360. So that would be enough for that one. We only have values up to 355, so we can stop there. And then we're going to go up by 5s along the y-axis. Okay, so our first point is at 21. We're going to have 9.62. So we're just plotting all these values as a scatter plot. 52. So what it should start to look like is that wave shape. So we do want it to be sinusoidal if you're doing this properly. Okay, so we did the scatter plot, and so that will be day of the year, T, and hours of daylight represented by H. Write a sinusoidal function that models the data, the number of hours of daylight. Okay, so there is a way to do this in your calculator to get a really accurate graph. What you can do is you can press Stat, Edit, which is number 1, and what you're going to do is in your L1 and L2, you want to enter these values here. So I'm just going to show you where that is on my calculator so you guys can see what I'm doing. Is you're going to go to Stat, Edit, number 1, and then in here L1, L2, you should be entering all those values that you guys see. So I'll write down those steps. Okay, so Stat, then you're going to go to Edit, which is number 1. Once you get there, if there is anything in there, you do want to delete all those values. And then what you're going to do is you're going to enter all of these values into L1, which is your X value. So the days of the year go into your L1, and your L2 is going to be your hours of the day. Once you have those on, what you want to do is once you've entered them, you're going to press Stat. Then you're going to press Calc. You're going to go to the right where it says Calc. And then you can actually find sinusoidal regression, which is letter C. Okay, so I'm going to enter these values right now to see what I get, and then you should be doing that as well. Now you want to be really careful about how you enter these values in, because if you make a mistake with entering these values in, your equation won't match what I have. Okay, so Stat, Calc, you're going to letter C, and then you're going to calculate your regression. So you should find that your A value in this case, so if I were to write this equation, the sinusoidal function that matches this for B is I could write y equals, your A value is 3.05 sine, then it's going to be your B value, which is 0.017. Then it's x plus c, which is going to be c is minus 1.32. Close your bracket, and then you would add your d value, which would be 12.14. Okay, so that would be one way to write the equation. The other thing that you could do is if you look at the equation, you could figure out the cos equation from just looking at where the maximum occurs and use that. So this is if you're looking at the features. The amplitude is always your max minus min divided by 2. So if you actually calculate your amplitude, max minus min divided by 2, you should find that it's 3.1. Okay, so this is using just our logic and how to find your A, your B, your C, and your D. Then I'm going to write cos because that's always easier to determine. Then your B value is 2 pi, in this case, divided by 365. So if I go 2 pi divided by 365, that is your accurate value for getting your B value. And I'll use letter T just to be more accurate with what they have in the equation. Minus our highest value, our maximum is reached on day 172, so that's what I would write for my my horizontal displacement, my horizontal change or phase shift. And then plus your vertical displacement is max plus min divided by 2, which is 12.18. So these are two equations. Now they might look like they're slightly off, but they are pretty close. So these values, that 1.32, if you factor out the 0.017 from the previous part, that will actually make it closer to the 172 that you guys see. So these are two ways to get the equation that matches the picture. You would graph it, which we already did. And it should kind of match what we have. If you were to put this into your graphing calculator, it would look like what we plotted for the scatter points. It might be slightly off, but it should still look the same for part C. And then for D, they want us to estimate the number of hours of daylight on each date. So what we need to do is figure out what day, like what day number each of those are. Like March 10th would be actually when x is equal to 70. So that would be day 70. July 24th would be day 203. So you're kind of figuring out how many days there are in each month and getting to July 24th. And then December 3rd would be day 328, from what I'm thinking. Yes. Okay, so once you have those are your x values. So what you can do is you can plug them into your equation for t and then just solve for the equation. So if you plug t as, in the first case, 70, and put that in radian mode into your calculator, you should find that for the first one, the answer should be about 11.6 hours. For July 24th, if you plug in 203 into t, you should find that the y coordinate is 14.8 hours of daylight. And for December 3rd, if you plug in 328 for t, you should find that the y value is 9.4 hours. Compare the graphs of Iqaluit and Windsor. What conclusion can you draw? Okay, so this is using our previous graph, so from a previous question, so we're not going to answer that one because we don't really have the Iqaluit one to compare it to, so we'll ignore question E here. And our last question, example number 5, it says this is the graph. They want us to write the equation in this form. So what I'll do is solve for A by doing the max minus min divided by 2 kind of steps. So for A, my max is equal to 17. If I subtract 1, which is my minimum, and divide by 2, I should find that the A value is 8. My next value is the B, which is always found by doing 2 pi, if you're in radians mode, divided by your period. My period seems to return back right here, back to its initial starting point at 30 seconds. So I'm going to write 2 pi divided by 30, and I would simplify that to pi over 15 for B. Our C value, I always like to, I prefer cos, because cos, you just have to look at the closest maximum and then line that up to see where it's moved to. So I know that it's moved, in this case, halfway between the values, I would say is 15. So I would say that it's gone 15 units to the right in this case. So it used to be at the y-axis, and it's moved 15 seconds to the right. And finally, the D value is found by doing your max plus min divided by 2. So that would be 17 plus 1 divided by 2, which is equal to 9. So I'll write it as cos, so H is equal to 8 cos, square brackets, our B value, pi over 15, rounded brackets, T minus our phase shift 15, close our square bracket, and then our vertical displacement is plus 9. So that's the equation they want. And you can always check this by then graphing in radian mode and seeing if it matches the picture that they have given for example number 5. Okay, so that is it for our lesson. I hope you guys understood that. Let me know if you guys have any questions about that, and don't forget